Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I came up with a new series, so that is YouTube plus app series. So in this YouTube class, I will teach you some concept here. Okay, after the concept, on the same concept, we are going to discuss at 11:30 in the BYJU'S Exam Prep app all the practice questions. So expertise in the regular grammars, all the theoretical aspects of regular grammars I will teach you now in the YouTube class, and the practice questions related to this regular grammars will be discussed in the app, BYJU'S Exam Prep app today itself at 11:30 a.m. So 11 to 11:30 this is YouTube session and followed by at 11:30 practice questions, so that in this particular small topic you can get expertise within 1 hour. Okay, so please try to make use of this facility and please join quickly and mark your presence. I hope I am audible and visible to every one of you. Am I audible? Is my audio, video, everything is clear? So please confirm me once. I hope I am audible and visible to all of you. Okay, so in this session I will be covering regular grammars. Okay, so welcome you all to my session once again. Welcome to the BYJU'S Exam Prep and warm welcome to my series that is GATE 2024 YouTube plus app series. So BYJU'S Premier League, Theory of Computation. Yes, and if any one of you not yet subscribed the channel, please do subscribe it and also share with your friends. Okay, so before I begin the session, let me introduce myself. Myself, Murali Krishna Bokkasamudram. I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And these are some of my credentials. I am topper of NPTEL course in Theory of Computation and certified as International Engineering Educator. And I have mentored more than 50,000 students across the country in different core areas of computer science. Those are Theory of Computation, Operating Systems, Computer Organization, Computer Networks, Digital Logic and ICT. So these are the areas in which where I am familiar with. Okay. So now we are going to discuss the regular grammars. So before that, so let me give you some of the information related to the workshops we are offering to you. How to ace the GATE exam in just 8 months. It's a live interactive session workshop by Rakesh Talreja sir. It is today at 7:30 p.m. Please try to make use of this facility. For this experienced faculty will be taking you some tricks and giving you some tricks regarding how to prepare just in 8 months. Okay, so please try to make use of this and try to register for this workshop. And GATE 2024 BYJU'S Premier League BPL. This is the YouTube plus app series. It is started today. Learn with BYJU'S Exam Prep with top faculties and get a good rank. So these are the faculties who will be teaching you all the classes related to the GATE, ISRO, NIELIT and all those things. And try to make use of this effectively and try to subscribe the channel for getting more notifications. Okay. Now let me introduce what is a regular grammar. Basically, regular grammars are meant for regular languages only. Okay, regular grammars you can design only for regular languages. Okay, so in regular languages we can have both left linear and right linear grammar. Okay, so the concept very clearly I will explain, and after that at 11:30 all of you please join at 11:30 in the app. Okay, that is for practicing the questions on regular grammars. So all productions of regular grammar are either a left linear productions or right linear productions. Usually regular grammar is usually on the left side having a single variable, on the right side there is a restriction. Okay, the restriction can be either it is left linear grammar or it is a right linear grammar. Every regular grammar is also a context free grammar, but all context free grammars are not necessarily be regular. Okay. So here regular grammars is equivalent to left linear grammar and also right linear grammar. A grammar is regular grammar if and only if it is either left linear grammar or right linear grammar. Okay, now coming to what is a left linear grammar. Usually the linear grammar in which only non-terminal on the leftmost and on the right hand side there is a restriction. Okay, that is what the linear grammar. And here V indicates a variable and T indicates terminals. Variable means all capital letters, terminal means all small letters. So left side is having a single variable, and if variable is deriving a single variable followed by any combination of terminals, T star indicates 0 or more combinations of T. Okay, so either only terminals. Then the production is called a left linear grammar. So we can have variable present on the left side, it is a left linear grammar. Something like, for example, if you have written something like S2 AAB or AB. So left side is a single variable followed by string of terminals or string of terminals. Then this will be taken as a left linear grammar. This left side variable can be either same variable or a different variable also. Okay, that is what the linear grammar meaning is. Each production of left linear grammar appears to be like V2, VT star or T star. And where V indicates a variable and T indicates terminals, set of terminals, all small letters, those are the alphabets in the language. And the left hand side of the production containing a non-terminal. Non-terminal means variable, so single variable. For example, I will give you a left linear example. For a grammar, for a regular language, both left linear grammar and right linear grammar can be written. For instance, you are having A of BA whole star. A of BA whole star. So what are the strings present in this regular expression? And you know that regular expression is possible only for regular languages. So single A is possible, A BA is possible, okay, A BA BA is possible. So A followed by 0 or more times BA can come. 0 or more times BA can come. And whenever you take this example, okay, I wanted to give a left linear grammar for this. Left linear grammar production style is like this. So it is something like A2. Okay, so A2 we can take something like this. So terminals followed by a single variable. Okay, so it is something like this. Just a moment. Okay, am I audible? Is my audio video everything is clear? Please confirm me once. So in the left linear grammar, we are having the productions like A2 alpha A or alpha. This is the right linear, sorry. Left linear is like this. A alpha. Okay, A2 A alpha or alpha, where alpha belongs to only terminals. If variable is present on the left side, it is a left linear. Or in more general format, if you write the more generalized format of left linear grammar, so that you can understand along with one example language also I brought it. So the more general form is something like A2 some BW or W. This is a left linear grammar. So what is this W? W is present in the terminals. W is present in terminals. And B is a single variable. Okay. Now coming to this, you can have any variable on the left side. Coming to this, we can have a productions like this. So grammar G, left linear grammar I am writing. S to A, minimum string is A, or minimum string is A, or we can have SBA. A or SBA. So starting symbol can derive either A or SBA. Variable present on the left side is a left linear grammar. So minimum string A can be derived just by using S to A. And if you want ABA, for example, ABA. So how can we generate S2? SBA we can take, and S place if you keep A, you will get ABA. Similarly, if you want ABA BA, for example, S2 SBA, and again S place we can keep SBA, and again S place we can terminate with A. Following? So here variable present on the left hand side. This is what left linear grammar. Okay. So you can learn what is a left linear, what is right linear. In this class, I will also let you know how to convert a finite automata into grammar. Okay. Then in the app class at 11:30, we will practice around 10 questions on only the regular grammars. Okay. I request everybody to please join the app class at 11:30 who are present here, and attend those, practice those questions, so that you will get complete knowledge about a regular grammar in today's session. Okay, shall I continue? So all of you, please, if you have any doubt or any concern, please let me know. Hi, Gate Easy. Good morning. Yes. Hello, John Philip. Yes. Suratkal and then Warangal. I think Warangal is better. Philip. Left recursion, right recursion, ambiguous, unambiguous, those are different concepts. And here only we talk about left linear and right linear in the regular grammar. Those things, ambiguity and all, we'll discuss in context free grammars. Okay. Now that is an example of left linear, and let us go with a right linear grammar, or simply it is RLG. So right linear grammar or it is RLG, we can just see. So right linear grammar means the productions are of the form, so A to WB or W, where W in T star. W is a word of only terminals, and variable present at the right hand side, it is a right linear grammar, and there is a single variable on the left hand side. Okay, following. And before you just go to this next slide, all of you please do subscribe the channel if you have not yet done it, and also please share with your friends. Okay, so double is a word of terminals, and for the same example, if you take language, considering like A of BA whole star, A of BA whole star, so we can give both left linear and also right linear grammar for this. So already A of BA whole star, I have given a left linear grammar, and right linear grammar for this I am writing here. So S2 minimum small a is required, or we can take ABS. So variable present on the right hand side is a right linear grammar. So for this, two productions are there. S2A is one production, S2ABS is one production. So derivation of strings I am showing you. S2A. What are the strings present in this language? The strings present in this language, like A is present, ABA is present. Okay, ABA is present. A followed by any number of B's. So S2A. Then you take S2 ABS, and S place if we put A, it will be ABA, and again S2 ABS, and again S place you can take ABS, and again S place you can take A. So AB, ABA also possible. Like that we can derive all the strings, and it is a string of terminals and followed by single variable, so it comes under the RLG. RLG means a right linear grammar. Hope you understood. Okay, and I will also give you some more examples for a right linear grammar. Is it clear? So what is a right linear grammar here? Just I am giving you the definition. You can just take it. This definition also you can write. Variable present on the right hand side of the production. The linear grammar in which only non-terminal is on the rightmost end of the production is called a right linear grammar. So right linear grammar, subset of linear grammars, and we are having the productions like this in generalized form. So it is something like V2, variable derives terminals followed by variable or only terminals. This is what right linear grammar is. And coming to conversion from finite automata to regular grammar, and before that I will give you one more example of right linear grammar. For example, we are having something like A plus B whole star. All of you listen carefully. A plus B whole star, AA or BB. So what is the meaning of this? All combinations of A's and B's. Okay, strings ending with either AA or BB. So strings ending with either AA or BB means minimum string is AA, or we can have BB, or we can have B followed by AA and A followed by BB. Okay, so AA BB or BB AA. Okay, and AB followed by AA, like this. So the ending string must be either AA or BB. So before that we can have any combination of A's and B's. That is a regular expression. Now let me give you a right linear grammar for it. All of you listen carefully how we can give a right linear grammar. RLG. Okay, so what is the minimum string? Minimum string is either AA or BB. String of terminals are valid. In addition to that, we can also have any combination of A's and B's followed by AA or AB. So for example, if I take AS or BS, you will get any combination of A's and B's, because S can be replaced with BS, or any S can be replaced with AS also. And finally S can be terminated with AA or BB. For instance, if you see some of the valid strings, so directly AA can be derived from S to AA, and also BB can be derived from S to BB. And if I take S to AS for example, and S place if we put BB, so ABB possible. And similarly, if I take S to BS and S place if we put AA, and BAA possible, and multiple number of A's and B's also, like S to AS if you take, and again S place you take BS, and again S place you take AA, so AB, AA also possible. This AS, BS can repeat any combination of A's and B's, so A plus B whole closure, and directly if you take AA or BB, this whole closure becomes epsilon, or if anything is replaced like AS or BS, finally this S must be terminated with either this part or this part, so that will give you all combinations of A's and B's ending with either AA or BB. Hope everybody understood. If you have any doubt, please ask me. Do you have any doubt on this? And don't forget to join the app class immediately after the class is finished at 11:30 to practice more questions on this concept. Now, before I conclude the session, I will just give you how to convert from finite automata to regular grammar. Okay. So the first step is conversion of finite automata to regular grammar means you have to take a DFA. Okay, initial state acts as a starting symbol, and if any transition is there like delta of A comma is equal to B, then A to AB is a production if B is not a final state. If B is a final state, A to AB or A is a production. And if initial and final state are same, then make them as separate like this. Let us suppose we are having a state A and state B. Okay, and we are having a transition between state A and B with input A, then the production equivalent right linear is A to AB we have to write. B does not belongs to final. If B is a final, for example, from A to B there is a transition with input A. If B is a final state, then we can have a production like A to AB will be there as well as A also will be coming. Like this we can write, or we can also write this as A to AB, and as B is a final state, B to epsilon I can write. If B to epsilon is substituted here, A also will come. That's the meaning. Okay, so that any grammar or any DFA we can convert into equivalent grammar. One example I'll tell you. For instance, we are having a DFA like this. S and A is a final state, and we are getting odd number of B's. Number of B's are odd, and number of A's can be any number. There is no restriction on number of A's, but total number of B's must be odd. So what are the states S and A? So accordingly, the variables in the grammar also will be S and A. Terminals are A and B. So based on the delta, what is the delta of S comma A? It is equal to S only. And the delta of S comma B is equal to A only. Okay. And delta of A comma A is equal to A. Delta of A comma B is equal to S. These are the transitions. And what is the final state here? Final state is equal to A. Final state is equal to A here. Then the equivalent production rules we can define like this. All of you listen. S to AS. That means S to AS we can write. Or S to BA. S to AS or BA. As A is a final, or B will come. And similarly A productions. Hope you are following. A to AA. As A is a final, small a also will come. And A to BS. Okay. So that means S is not a final, B will not come. Either this way we can write, or the other way also I am just writing. So S to AS or BA and A to AA or BS or epsilon. So A to epsilon will come because A is a final. Either this grammar or this grammar language remains same. Only thing is directly epsilon has been removed here, and here epsilon is included. If epsilon is substituted in the place of A, B will come. And if this epsilon is substituted in the place of this A, this small a will come. It makes absolutely no difference. Without confusion, I am just telling you two methods of writing the grammar for a final state. If starting is final, S to epsilon will be remaining. Hope everybody understood. Is it clear? And if not, please let me know. And I shall move on to the next question. And meanwhile, if any doubt or any concern, please ask me. Don't hesitate to ask. I will take one more example. So if you want actually odd number of B's now, I will show you generation of one string. For example, I wanted to generate AB, ABB. This is total number of B's are odd, and A's can be any number. So we can take S2, this either this or this we can take. S2 AS I can take. Okay, and again next I want B. So S place BA I can take. Okay, again A place small a you should get, and AA we can take. Again A place, one more B is required. No, A place I can take BS. That is only the possibility we have. And again S place we can take BA. So AB, A, S place if I take BA, and A place I can take epsilon. If I take epsilon as A place, so it is AA, ABA, BB. Total 3 B's. A to epsilon is nullified here. Like that we can generate the strings. So that is how we can convert a finite automata into a regular grammar. So but directly we get a right linear grammar. Do you have any doubt? And meanwhile, please do share with your friends, and also subscribe the channel if you have not yet done the subscription. Okay. Shall I go ahead, everybody? Now coming to one more example. So example 2. Let us suppose we are having a DFA like this. DFA for some certain language I am taking. It is S, A and B. This is a DFA for a language something like number of zeros not a multiple of 3. Okay, number of ones there is no restriction. There is a restriction on number of zeros. Those should not be multiple of 3. So language of this can be written like this. W is such that W is any string of zeros and ones. W is any string of zeros and ones, and n suffix 0 of W mod 3 not equal to 0. What does it mean? When you count the total number of zeros present in the W, okay, total number of zeros should not be multiple of 3. That means single zero, not a multiple of 3, it is accepted. Double zero accepted. Triple zero is a multiple of 3, not accepted. And ones can come any number of times anywhere. That's why ones are given as a self block. So there are two final states here, A and B. How can we give a regular grammar for it? So the variables. So for these, how many variables will come? Can anybody tell me? What are the variable set? Variable set is all the state names. So S comma A comma B are the state names. These are the variables. Hope you are following. Okay. Now coming to grammar productions of right linear. So S2 1S, because delta of S comma 1 is S. That means we can write 1S or 0A. S on 0 it goes to A. That's why we have to keep 0A. And A production. S is not a final state, so we don't keep epsilon S productions. Okay, and A2 1S, 1A, sorry. 1A or 0B. On 0 it goes to the state B, or for 1 it goes to the final state. That's why, and we will either single one we can write or epsilon also we can write, as A is a final state. And B to epsilon also will come because B is final. So B to 1B will come. Okay, that is one option, and also 0S. And then epsilon. Why epsilon? Because B is also final. Say for example, if you take a string, something like, as an example I am telling you, one string like, let us suppose 010010. It is a valid string because the total number of zeros present in the string is a 4. 4 is not a multiple of 3. It should accept. That means your grammar should generate this string. Okay, I will show you how to generate the string. The derivation part is like this. S2 0A we have to take, and A place again one more 1 we want. So A is replaced with 1A, and again A we want 0. So A is replaced with 0B. Again we want 0 in the place of B, means you have to take 0S. And again 0 1 0 0 came, 1 0 we want, So 0 1 0 0 s place we can take 1s, and again s place 0a we can take because the last 0 is required, and a is providing epsilon, so we can write 0 1 0 0 1 0, a is epsilon, so it will become 0 1 0 0 1 0. So finally it is generated because it is containing number of zeros, not a multiple of 3. 4 is not a multiple of 3. Okay, like that we can derive the strings. Okay, the questions related to regular grammar will be grammar will be given, language will be asked, or language will be given, grammar will be asked, or else DFA will be given, grammar will be asked, or grammar will be given, DFA will be asked. Like that, any type of question you can answer if you are thorough with this. So usually when you are converting from this DFA to regular grammar, what happens is, if a P comma Q are the two states, for example, if there is a transition between P and Q with input A, we can say delta of P comma A is equal to Q, then equivalent right linear production is P to AQ if a Q does not belongs to final. This is the case where Q does not belongs to final. Same is the case if Q belongs to final, for example, like this. If B belongs to final, A to AB and B to epsilon we can write. A to AB and B to epsilon we can write, or A to AB or A we can write, either one if B belongs to final state. So that is the criteria. Hope everybody understood, and if you get any doubt, please ask me. That's all for today. And in this session we have discussed about all the important concepts related to regular grammars, both left linear grammar and right linear grammar. And I request everybody to please join the app class. Please open the BYJU'S exam prep app. If you are not yet downloaded, please download it. Okay, and do subscribe the channel, and you can continue right now at 11:30. I'm shifting over to app class, and there I brought around 10 questions only for practice. Okay, so if you don't practice that, there is no use with this class. Okay, so I request everybody to finish that and get expertise in regular grammars. Okay, thank you so much. Thank you, one and all. Meet you again in the app class. Thank you. Bye bye. See you all.